Hi everybody. Well, here we are doing section 4.6 practice problems, and we're just going to start on the first one. And here we have a situation where a person tosses a coin and then rolls a six-sided die, and we're going to try to write down the sample space. The sample space is the set of all possible outcomes, and when you first toss the coin, you can either get a heads or you can get a tails. Now, that's for tossing the coin, but then when we roll the die, there's six possible outcomes, which are 1, 2, 3, 4, 5, and 6. So for the first toss as a head, then you can get 1, 2, 3, 4, 5, 6 for rolling the dice. But then, if the first time you get a tails, you can have 1, tails 2, tails 3, tails 4, tails 5, tails 6. So we see there's 6, under tails there's 6 possible outcomes. That makes 2 times 6 is 12 possible outcomes. What's the probability of tossing a head and then rolling a 2? Well, head 2 is just one item, one element in the set of S. And to find the probability, we write number of heads 2, well there's only one of those, divided by the number in S. So there's only one heads 2, that's only one thing that could happen out of 12 in total. Under this method of finding the probability, what's assumed is that each of these 12 items has an equally likely possibility of happening. Equally likely probability of happening. Now let A be the event that heads is tossed. What's the probability of A? Well, let's first list out what A is, which is sort of a little bit of trouble because it's long, and also we did a lot of that up above anyway. But let's just list down what A is. So A is when you get H first, and so I'm doing that. Okay, so what I see is I see that this is what A is. That's an event, which is a subset of the set S. And to find out the probability of A, we take the number of elements in A divided by the number of elements in S. So we see that there's 6 elements in A, so that's 6, and then 12 in S, so that's 6 twelfths, which reduces to 1/2. And now let B be the event that 4 is tossed on the die. What is the probability of B? Well, let's list all the elements in B. So how can you get a 4? Well, you could have first heads in 4, and then you could have tails in 4. So those are the two elements in B, the 2 ways you can get a 4 and just toss on the dice. And then the probability of B is equal to the number of elements in B divided by the number of elements in S. So how many are in B? There's 2 elements. How many are in S? There's 12, and that reduces to 1/6. And now, what's the probability of A union B? Well, to find this, we can use the formula which says that the probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Now we already have the probability of A and probability of B written down. Let's work on A intersection B. What's A intersection? A intersection is the part that's in common to both A and B. So here's a little drawing right there. So that's the intersection right there. And so what do A and B have in common? The only thing they have in common is a heads 4. And so we see that the probability of A intersection B is the number in A intersection B divided by number in S. So that's going to be just 1 out of 12. Now, using this formula that I have up above here, which is one that we're going to memorize, I have the probability of A union B is going to be the probability of A, which is 1/2. Instead of using 1/2, I'm going to use the unreduced form, 6/12, because that's how I can add and subtract fractions, is having the same denominator. So if I have it unreduced, then they both have a denominator of 12. So it's probability of A, which is 6/12, plus probability of B, which is 2/12. Now, minus the intersection, minus 1/12. And this is 6 plus 2 is 8, minus 1 is 7/12. Okay, so that finishes the first worksheet. Bye.